Good day everyone! So today we're going to talk about parabolas. Parabolas is a type of conic section, and we often see parabolas in motion, just like water in the fountain. It creates a parabola. When a frog hops, it creates a parabola. And when you throw a ball, it creates a parabola. And architects are fond with parabolas when building or designing infrastructure. In this discussion, we're going to talk about parabola in bridge. Bridge is an example of infrastructure. So this diorama is inspired with the Golden Gate Bridge in San Francisco. The bridge creates a parabola because it has a suspension or a cable suspension. The point that is lowest and highest in a parabola is called a vertex. It is the lowest point or the highest point in the parabola. But this parabola is opening upward. So, our vertex is the lowest point of this parabola. And this is the directrix. Directrix is an equation, so it is a line. The distance between the directrix and the vertex is the same with the distance between the focus and the vertex. Focus is a point that is aligned with the vertex. It is inside the parabola. And the 2 points that passes through the focus is called latus rectum. So we're going to use this diorama in our worded problem later. So we have here the general form and the standard form of the parabola. The general form is x squared plus dx plus ey plus f is equal to 0. And the standard form of the parabola when the vertex is not in the origin is x minus h close and open parenthesis squared is equal to 4p open and close parenthesis y minus k. But if the vertex is at origin, then our standard form is x squared plus 4py. So in example number 1, the vertex is not in the origin. So the Golden Gate Bridge's cable are shaped like a parabola. The length of the bridge between the towers is around 1:80. So let's draw a figure. That is the Golden Gate Bridge. And the measure between the towers is 1,280 meters. Here. And the tower's height is approximately 227 meters above the bridge road. So, from this to the bridge road, it is 227 meters. The cables were about 30 meters long and went halfway between the towers. So, in the halfway or in the midway of the parabola, the height of the cable is 30 meters. And assume that the axis of symmetry runs along the y-axis. So the axis of symmetry passes through the vertex. And according to the problem, axis of symmetry is along y-axis. So this is our y-axis. And the road bridge runs along the x-axis. X-axis. Now, what is the height of the cables 300 meters from the bridge center? What is the height? Assume that this is for 300 meters. What is the height of this cable? Okay, so in this illustration, we're going to evaluate the given. Our vertex is here. So, this is the y-axis and this is the x-axis. And we can say that 30 is our y and 0 is our x. So our vertex is 0, 30. And for our x and y intercepts or x and y value, we're going to have 1,280 and 227. Since the given is vertex and the x and y, we are going to use the standard form to find p. So we're going to substitute x minus h squared is equal to 4p y minus k. X is 1,280 minus our h is 0 squared is equal to 4p. Y is 227 minus our k is 30. So we need to apply the operation and 4p. 227 minus 30 is 197. And the square of 1,280 is 1,638,400 equals 197 multiplied by 4p is 788p. We need to divide both sides by 788 to cancel the coefficient of p. So our p is equal to 2,079.187. This is our p. But the question in the problem is, what is the height of this cable when it runs along 300 meters away from the center? So we will create a given. Our xy is 300 and our y is unknown. And our vertex is the same, which is 0, 30. We're going to substitute that to be able to get the y, or the height, in 300 meters. Okay. So, coming back, x minus h squared is equal to 4p y minus k. Our x now is 300 minus h is 0 squared is equal to 4p. What is our y? It is unknown. Minus 30. So 300 squared is equal to 4. What is our p? 2079.187 multiplied by y minus 30. So 300 squared is equal to 90,000. And we're going to multiply the value of p to 4, and it will result to 8,388.76 multiplied by y minus 30. Okay. So when we multiply this and distribute this, we're going to have na 8,388.76y minus 251,662.8. And we can transpose this to the left side because we're going to isolate y. 90,000 minus 250 plus 251,622.8 is equal to 8388.76y. Next, we're going to divide this and we will get 40.7286 for our y. Okay, so wala tayong space. Going to erase this. So there, in your problem, you are required to give your answers in nearest meters. So you will round off your value of y and you will get 341. So your height is 41 meters. There you can say that your answer is the height of the cable when it's 300 meters away to the center of the bridge is 41 meters. So that's your answer. It's 41 meters. And for our number 2 vertex at origin, our problem is the cable of the Golden Gate Bridge hangs in the shape of parabola. The size of the bridge between the towers is about 1,280 meters. So it is like number 1 problem. 1,280 meters. And the tower's height is about 227 meters. 227 meters above from the bridge road. If the cable's lowest point, so we discussed earlier that the cable's lowest point is our vertex, is at the road bridge. So here it is touching the road bridge. What will be the height of the cable 500 meters away? 500 meters away. So let's write it. 500 meters away from the center, assuming that the axis of symmetry runs along the y-axis. So it's like the condition before. And the road bridge runs along the x-axis. Okay. State your answer in the nearest meter. So we can say that the vertex is at origin. And the standard form that we're going to use is this one. X squared equals 4py. Okay? So we're going to evaluate and write our given. The vertex is 0, 0. And our xy values is 1,280 and 227. So we're going to substitute to be able to get the value of p. X squared is equal to 4py. Our x is 1,280 squared is equal to 4p. What is our y? 227. The square root of 1,280 is 1,638,400 is equal to 4p multiplied by 227 is 908p. So to be able to cancel the coefficient of p, we're going to divide both sides by 908. Cancel and divide this one. And it will result to 1,804.41. And that's our p. Next, now that we get our p, we're going to evaluate the new xy value. Our x is 500 meters and our y is unknown. So we're going to get the y in the equation of x squared equals 4py. Going to substitute. Our x is 500 squared. For our p is 1,804.41 and our y is unknown. 500 squared is equal to 250,000. 4 multiplied by 1,804.41 is 7,217.62. And when we multiplied this to y, we're going to get 7,217.62y. Okay? To be able to cancel the coefficient of y, we're going to divide both sides by 7,262. Okay? 7,000. Cancel. And when we divide this, we're going to get 36.637. So that is our y. So we can say that our xy value is 536.6. But you are required to state your answer in nearest meter. So our y is 37 meters. Now you can say that the height of the bridge when it is 500 meters away from the origin it is 37 meters. So that's your answer. So in that two examples, I hope you understand and learn to analyze and solve a worded problem involving a parabola. So you have to remember that The general form of a parabola is x squared plus dx plus ey plus f is equal to 0. And if the vertex is not in the origin, we will going to apply the equation x minus h close and open parenthesis squared is equal to 4p open and close parenthesis y minus k. And if the vertex is at origin, you are going to apply the form x squared is equal to 4py. Thank you for watching and have a good day.